Day 413 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1048, longest string chain. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of words where each word consists of lowercase English letters. Word A is a predecessor of word B if and only if we can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to word B. For example, the string ABC is a predecessor of the string ABAC, while the string CBA is not a predecessor of the string BCAD. A word chain is a sequence of words where word 1, word 2, all the way up to word K, with K being greater than or equal to 1, where word 1 is a predecessor of word 2, and word 2 is a predecessor of word 3, and so on. A single word is trivial word chain with K1. Return the length of the longest possible word chain with words chosen from the given list of words. All right, y'all, so I can understand how that question may be a little bit difficult to understand. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have the input words equals an array of strings A, B, BA, BCA, BDA, and BDCA. The output is 4. Explanation says one of the longest word chains is A, BA, excuse me, y'all, is A, BA, BDA, and BDCA. All right, y'all. So let's go ahead and break this down one step further. So as you can see, we're starting with A, right, in the example that they give us, or the longest word chain that they give us. We start with A, right? So we have A right here. We can insert one letter into this string, which will make it equal to this string, right? All we have to do is insert a B into this string, and it'll equal this string, right? So we can add BA to our word chain. Then we have BCA, right? Or BDA, either one. In this case, they use BDA. So from BA to BDA, all we have to do is insert one letter, right? Which is D. In this case, we insert D into this string, and then this string becomes equal to this string. So we can include BDA into our word chain. Then finally, we are left with this, where all we have to do is insert a C into this string, right? So if we have BDA and we insert a C after the D before the A, then BDA becomes BDCA, right? Because we only had to insert one letter, which means we could add that to the word chain as well, with the final word chain being this right here. Now, it's important to understand that this is one of the longest word chains. It's not the only longest word chain. If, for example, we could start with a B, and then all we have to do is insert an A, and we'll go from B to BA. That works as well. We could do that. Same with this. We could go from BA. We can insert the C here, or we can insert the D here. Either one, we can insert a C into BA and we'll get BCA, or we can insert the D into BA and we'll get BDA. Either one will work. And then finally, if we have BCA, we could just insert a D right here, or we'll insert a D into BCA and we'll get BDCA. Or if we have BDA, we can just insert one C and we'll still get BDCA. So there are multiple ways to create the longest word chain. In this example, this is just one of the longest word chains that they give us right here. So, but if you came up with another longest word chain, don't worry, there are multiple ways that we can achieve this longest word chain that still has an output of 4. So in case that didn't make sense, let's go ahead and take a look at example 2. Example 2 is same principles apply, but we're going to go through it anyway. So in example 2, we have the input words equals an array of strings XBC, second string PCXBCF, third string XB, fourth string CXBC, and the last string PCXBC. This time the output is 5. Explanation says all of the words can be put into a word chain, with the word chain being XB, then XBC, then CXBC, then PCXBC, and then PCXBCF. So in this example, you can see we're not starting from the beginning to end like we did up here, where we added as we went on. In this example, we're starting from the middle index with XB. Then from XB, we can add a C, and then we'll get this right here. We'll get XBC. Then from XBC, we can add another C, and we'll get this right here. Boom. Then from this right here, we can add a P, and we'll get this right here. And then from this right here, we'll add an F, and we'll get this string over here. So as you can see, in this example, we can use all of the strings in our word chain, which will give us an output of 5. But it's important to understand with this example that we do not have to go in the order of indexes. Like up here, the indexes kind of went in order. Down here, the indexes are not in order at all, but we are still able to create a word chain from the strings that they give us. We start at index 2, then we go back to index 0, then from index 0 we go to index 3, and so on, just so you can see that it does not have the words may or may not be in the indexes may or may not be in order in our input. So let's take a look at example 3, final example where we can only use one of the strings for our word chain. So in example 3, we have the input words equals an array of strings. First string A, B, C, D. Second string D, B, Q, C, A. Output is 1. Explanation says the trivial word chain A, B, C, D is one of the longest word chains in the array of strings A, B, C, D, and D, B, Q, C, A is not a valid word chain because the ordering of the letters is changed. So as you can see, once again, it says, one of the longest word chains. So either way, we can only use one string. We can use create a word chain with this string, with this string right here, or we can create a word chain with this string right here. But either way, the length of the word chain is only going to be 1 because the letters in this string we cannot insert any letters into this string that will create this string without rearranging the letters. And remember, we're not allowed to reorder any of the letters. We can just insert letters. We can't rearrange the string. So we need to understand that as well as we're writing our code. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get started. Now, the first thing we're going to do, we're going to create a dictionary to store the longest chain ending with a given word. So for that, we'll declare a variable. We'll call it DP. We'll say colon, open up the square brackets. It's going to be a string, a dictionary with a string, colon, integer. Then we're going to come outside of that. We're going to say equals a blank dictionary just to initialize it with the blank dictionary to start. Now we need to sort the words by length in ascending order so that we can build chains from the shorter to longer words. So we're going to say declare variable called words. We're going to set that equal to words.sorted. Open up the parentheses by colon. Then we're going to say $0.count. Then we're going to come outside of that and say, or after that and say less than $1.count. Now this $0 and this $1 represent each element in the array. So this could be if this is $0, this is $1, and it's going to go through each of these and find which string has the larger count or the smaller count, and it's going to sort it by count, right? So make sure, similar to this in example 1, where the words with the shorter count come before the words with the longer count, right? But since we might be dealing with an example like this, that's why we have to sort them ourselves, because they're not always going to be given to us with a sorted with the count of the string or characters in order like it is here. So boom, and sorry y'all, we're gonna have to put this in some brackets. So we could just wrap that in brackets like that. Boom. Now we need a variable to keep track of the maximum chain length so found. Now we can declare a variable and we can say longest, set that equal to 1, because it'll always be at bare minimum we'll at least have one string for our word count or for our word chain, so that's why we're going to start the count at 1. Boom. Then we need to iterate through each word in the sorted list, so we're going to say for word in words, we're going to open up the brackets. Now we're going to start with a default chain length of 1, which will be the word itself. So we're going to declare a variable called present length, and we're going to set that equal to 1. Boom. Now we're going to try removing each character from the word to form possible predecessors. So for that, we're going to say for I in 0 ... less than sign word dot count. We're going to open up the brackets and we're going to convert the word into an array of characters. So we can say new str equals, oh sorry, it should be var, so it's going to be a variable new str. Then we're going to say array, open up the parentheses, and pass in word, and that's going to convert the word into an array of characters for us. Now we need to remove the character at position I to form a possible predecessor. So we're going to say new str dot remove, open up the parentheses, at :I. Now we need to look up the chain length of the predecessor word, and we're going to default the value to 0 if it's not found. So we're going to say let prvl equal dp square bracket string, open up the parentheses, new str, because remember right now str is an array. We have to convert it back to a string because our dictionary takes strings. Then we're going to say comma default. Our default value is going to be 0 when we're keeping count. Boom. Now we need to update the current word chain's length if a longer one is found. So we'll come underneath this and we'll say present length equals max. So it's going to get us the bigger value of prev l plus 1 comma or present length. Whichever one is longer, that's what it's going to return for us. Boom. Then we're going to come underneath, we're going to come outside of this for loop, still inside the initial for loop, and we're going to store the longest chain length for the current word. So we're going to say dp square bracket word. Come outside of that, we're going to set that equal to present length, just like that. And then we're going to update the overall longest chain if needed. So for that, we'll come underneath this and we'll say longest equals longest less than present length. So this right here is going to return a Boolean for us, right? So if this is true, then we're going to say question mark, and if it's true, it's going to return present length. Otherwise, we're going to say colon. Otherwise, it's just going to return longest if it's false. Boom. And now we need to return the maximum chain length found. So for that, we could just come right here and say return longest. Now that should be all she wrote, y'all. Let's go ahead and give it a run before we submit it. Make sure it's running properly. Let's see, it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 135 milliseconds beats 60% of users. We can definitely get those numbers up, but we'll worry about that further down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us. Feel like this is a good solution for that, y'all. So easy to understand. We can all learn from it. So with that being said, make sure you get one more look at the code. This is the top part of the code. This is the bottom part of the code. And yeah, hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.